Hello, welcome to this part 3 of a 4-part series to do with comparing images, various images, with a right-of-way definitive map. In part 1 we did the comparison with aerial views. Part 2 it was a comparison with old OS maps, and in this part 3 we're going to do a comparison with a modern up-to-date OS map. So here I've loaded a section of definitive map, a different one to the one used in parts 1 and 2, and I've already traced out part of footpath SD228, and in particular we're interested in the area around Haven Pastures, which is a new development on top of an old golf course. So the question here is this footpath obstructed by the new development? And we'll answer that question in this video. So I need to make a few points about this extract from the definitive map. The first is that it's exactly a kilometre square and exactly 3000 pixels square. That means it's 3 pixels per metre. The other point to make is that it's perfectly aligned on an OS NGR 1 kilometre square, and we'll use that information later. That's going to be quite useful. So let's pull in now the OS map, and the first thing we can see about this is that this is a much larger scale than the underlying definitive map. I'm going to zoom in a little bit here and go down to the bottom. And across the bottom here you can see these numbers. So that's 415,700. So that means that this line here is 700 meters from the left-hand edge of this national grid square. And you can see that from here to here is 50 meters, from here to here is 100 meters, and another 100 meters here. So along this line here, we've got a line of 200 meters. So the next thing we'll do is we'll measure how many pixels long that is, and we know it's 200 meters, and therefore we can work out how many pixels per meter is in this OS map. So let's do that next. But to do this, we need to use the measuring tool. So go up here, and we can place this as accurately as we can. Accurately as we can. And here again, when making these measurements, accuracy is everything. So we want to measure from here. Let's get that really, really accurate. From here across to here as accurately as we can. And we can see here, if we look down here, that this is 1889.0 pixels. So let's do that calculation now. So let's feed in here the number of pixels across that 200 meters and divide that by 200, and there we have the values. So that's the number of pixels per meter in this current image. So we need to work out what the ratio of that is to the underlying image. Obviously it's going to be smaller, so we need to do that. Multiply that by 3, and there we go. So that's, in terms of a ratio, is how much we have to reduce the size of this OS map. But we need that in a percentage. Turn it into a percentage like that. So let's grab that value at a handful of decimal places, and now we have what we need to be able to scale this. Scale the layer, leave the value in there, scale it, there we go, and that's what we've got. Now we can see here straight away that this is about the same scale, so that looks about right. However, we need to position this, and we can't position this the same way we did previously because there's not enough detail in this to match up roads and bits and pieces like that. So even if we made this a bit see-through, we've got nothing to match it against. But better than that, we've got the numbers down here, and the numbers down here make it very easy to do this to do this positioning. So let's use these numbers at the bottom. So I'll just zoom in a bit so we can see what we're doing. There we go, down here, and you can see here we've got this number here, 415,700. Perhaps I ought to go in a bit closer. Well, I think that'll do. 415,700. So what this means is that this line here needs to be 700 meters from the left-hand edge of the 1 kilometer square. Now we know that this definitive map and this 1 kilometer square is 3 pixels per meter. So this 700 meters times 3 is 2,100. So down in this bottom corner here, as we move the cursor about, it shows us in pixels where the cursor is. So we need to make sure that this line here is 2,100. So if I shuffle this across a little bit like this, 2,100. There you go. So that line is about 2,100. So that's pretty accurately exactly where this should be, left and right. We also now need to get it up and down. And if we look at this figure here, this is 268,350. So that means it's 350 meters up from the bottom. But the pixel measurement goes from the top down. So it needs to be 650 meters from the top of the 1 kilometer square. Now, 650, we then need to multiply by 650 by 3, and I don't want to do that in my head, so I'll just jump out now. So yes, I wasn't confident to do that straight away in my head. So this needs to be 2,100 pixels from the left-hand edge and 1,950 pixels from the top edge. So that's the numbers we need to see down in this bottom corner here. So let's grab hold of this. I'm going to go even more accurate here. Let's grab hold of this particular point just here, and let's move this until we get 2,100 in the bottom. This is going to be a bit fiddly, so I'm going to go offline while I do this. So I've done that now, and if I place the cursor in the right place here, and you keep an eye on the figures down there, I think you can see that 2,100 and 1950, there we go, and the cursor there is bang on the right spot. So we now have the map perfectly aligned, the Ordnance Survey map perfectly aligned on top of the definitive map. So let me just zoom out a little bit now. And wander up here, and what I'll do now is I will turn on, I'm going to go in a little bit more, get a bit more accurate than that. There we go, something like that. So what we can now do is we can now turn on the footpath that we have running across here, and there it is. And we can see now immediately that this property here called Pasture Croft is obstructing the footpath in 2 places. And just to show that this is right, I can drop out the Ordnance Survey map showing the line of the path over the definitive map and then put it back again, and you can see that we've got a perfect alignment there. We know exactly where that is. So that solves that problem. So we know now with some high degree of accuracy that Pasture Croft is obstructing this footpath in 2 places. Now, using this method, we can get accurate to less than a meter, I reckon. Perhaps if it's 3 pixels a meter, perhaps we can get an accuracy of 1 pixel using this particular method. So in this video, I've shown you how you can take a modern OS map and match it very accurately to within really a fraction of a meter to exactly where the footpath goes according to the definitive map. Now, the snag with this method is that you have to buy these maps, and they're not cheap. So this particular map cost me £25. What you've also got to bear in mind, got to make sure when you do this, is that you do get a map which has the grid lines on it, because that's vital both for the scaling and for the positioning. Thank you very much.